Section 2.6, Solving Equations by Multiplying or Dividing. Before we get started on the rules for solving equations by multiplying and dividing, I want to take a look at fractional notation. Here I have a negative 3/5 in three different spots on the screen. And notice, in the first one, the negative is in the numerator, the negative on the second one is straight out front, and in the last one, the negative is in the denominator. And I want you to realize that even though the negative sign is placed in different spots on each one of these fractions are all the same value, even though the negative is placed in a different location. Each is known as a negative 3/5. So when you see this, don't get nervous. Just understand each notation may look different, but essentially it's the same exact problem. Next, our rules for multiplication property of equality. That means that I can multiply the same value to each side of the equation and it does not change the equality. The arithmetic version looks like this. 12 equals 4 times 3, which is 12. And if I multiply both sides by 2, it does not change the equality. The left side still equals the right side. 12 times 2 is 24, equals 12 times 2 when I simplify, which in the end is 24 equal to 24. The algebraic version is letting A and B be any real number, but they are equal. A and B are equal. And if I multiply each side by the same value, here, C, then the equality is still holding for this equation. AC equals BC. And now I have the division property. Again, if I divide each side of the equation by the same value, the equality does not change. Here I have again 12 equals 4 times 3. The left side equals the right side. If I divide each side by 3, and I can do that quickly here as the 3 cancels the 3, that'll leave me with 4. And 12 divided by 3 is 4. You can see the left side equals the right side. And the algebraic version, here I have A equals B, and again I have to say I cannot divide each side by 0 because then the equation would be undefined. But if I divide each side by the same value, here's C and C, this equality still holds. Here's a procedure to solve equations by multiplying or dividing. Number 1, copy the problem from the book. Number 2, simplify if possible. Number 3, start on the variable side of the equation. All similar to what we've done before. Number 4, check to see what's happening to the variable. And here's the questions. If a number is multiplying the variable, then divide both sides by that number. And B, if a number is dividing the variable, then multiply both sides by that number. And number 5, simplify if needed. Now let's take a look at some examples. I'm going to solve each equation. So what I want to do is very similar to what I have on our previous section, which is adding and subtracting to solve equations. I want to copy the problem down, which I will do here. I want to simplify. This is simplified. I want to start on the side with the variable, and that would be on the left side. And I want to do the inverse or opposite of what is happening to my variable. What's happening to my variable is 4 is multiplying my variable. What is the inverse of that? I divide. And now I'm going to divide both sides by 4. And again, I'm dividing both sides by the same value, so the equality will not change. 4 divided by 4 leaves me 1x, or just x. You can put the 1 there, but you don't have to. It's never shown, but we know there is a 1 there. Equals 32 divided by 4, which we know is 8. So x equals 8. Number 2, copy the problem. 24 equals a negative 10z. I start on the side with the variable, which in this case is the right side. I look to see if I need to simplify. I don't need to. What's happening to my z is I'm multiplying by a negative 10. Therefore, I want to divide by a negative 10. And when I do that, 24 divided by a negative 10, positive divided by a negative is a negative. And now I want to simplify this. What goes into both 24 and 10? Answer to that is 2. 2 goes into 24, I get 12. 2 goes into 10, I get 5. Equals negative 10 divided by negative 10 leaves me 1, z. And in this case, I can leave this improper fraction, but the improper fraction is simplified from the original. In other words, no factor can go into both. There are no other common factors. Number 3. Again, copy the problem. Check to see if I need to simplify. I don't. Then I start on the variable side. Here, what's happening to the m is that I'm multiplying it by a negative 16. And what I'm going to do is now divide by the negative 16 on both sides. A negative 16 divided by a negative 16 is 1m. And a negative 48 divided by a negative 16 is going to be a positive 3. Number 4, m divided by a negative 2 equals a negative 21. Want to copy the problem? I check to see if I can simplify, which I can't. I start on the variable side, which is on the left side, and then I want to determine what is happening to my variable. M is being divided by a negative 2. The opposite or inverse of being divided by is to multiply. So I'm going to multiply both sides by a negative 2. So I have a negative 2 times m, which is a negative 2m, but a negative 2 divided by a negative 2, they cancel, leaving me 1m, or just m. And now I multiply. A negative times a negative is a positive 42. 5. 7 equals a negative divided by k over 5. So what I want to do here is recopy the problem, rewrite it. And the easiest thing for you to do at this point is to probably put that negative sign down with the number. So if I move that down, I can then determine what's happening to my k. My k is being divided by a negative 5. So the inverse of that is to multiply by a negative 5. And notice I use parentheses to show multiplication. On the left side, a negative times a positive is a negative. 5 times 7 is 35. And negative 5 times 1 is a negative 5, but a negative 5 divided by a negative 5 is 1, k. K equals a negative 35. Number 6. I want to recopy the problem, v over, and again, I'm going to move that negative down with the 4, just makes it easier, equals 9. And again, on these last two examples, we notice that I'm allowed to move that negative around because I showed you the notation for fractions that have negatives. I can put it on top, leave it in the middle, and put it on the bottom. But sometimes it's easier to put it on the bottom. So here, I can now determine what is happening to v. V is being divided by a negative 4. So I'm going to do the opposite, or inverse, which is to multiply by a negative 4 on both sides. When I do that, a negative 4 times 1 is a negative 4, but a negative 4 divided by 4 is a positive 1v, equals a negative 36. Let's look at a few more examples. Here I have number 7, which is 7 divided by g equals a negative 6. Here, my variable is in the denominator. And when I solve my problems, I need to have my variable in the numerator. Therefore, that's the first thing I need to do. So I'm going to rewrite the problem and get that variable in the numerator. The procedure to do that is to take a look at the side that it's on and then determine what is happening to the numerator. The numerator is being divided by that variable. Therefore, I want to do the inverse of that. Since g is dividing 7, dividing into 7, I want to multiply by g on both sides. Now, again, since I'm doing that on both sides, it holds with the property of equality, as long as I do the same thing to both sides. So here, if g just happened to be 5, 5 divided by 5, they would cancel out and I'd be left with 7. So since g is the same value would be in the numerator and denominator and cancel out, leaving me with the numerator, which is 7. And then on the right-hand side, a negative 6 times g is a negative 6g. Now I go back to my regular rules. Again, I start on the side with the variable, which is here. What's happening to my variable? A negative 6 is multiplying it. I'm going to use inverse and divide both sides by a negative 6. And that gives me a solution of 7/6, but it happens to be negative. And that is equal to G. G equals a negative 7/6. And this is simplified. Number 8, 5 equals a negative 8 over x. I'm going to recopy the problem. 5 equals a negative 8 over x. And it's easier if I move that negative up with my number. I'm going to start on the side with the variable, but notice my variable is in the denominator. Again, I need to get it in the numerator. To do that, I'm going to determine what is happening to my negative 8. It's being divided by my x. So I'm going to multiply both sides by that variable. And when I do that, the x's will cancel, and that gives me a negative 8. Or in other words, x divided by x. And anytime you divide anything by itself, it's 1, so it cancels and gives me a negative 8. And here, this is 5 times x, and it's always the correct notation to put the coefficient out front of the variable, not behind it. So that's 5x. Now again, I go back to the variable side. What's happening to my variable? It's being multiplied by 5, so I'm going to divide by 5. And I get x equal to a negative 8/5. Our next example. A car is estimated to go 30 miles per gallon on the highway. If you wish to travel 250 miles, what is the minimum number of gallons of gasoline you should purchase? I don't know how many gallons I need to purchase, so that's going to be my variable. So G equals my variable, and that's going to represent gallons, the number of gallons. But I do know for every gallon I purchase, I should be able to travel 30 miles. So I can set up an equation of 30 times G. So if I go and purchase 1 gallon, 1 times 30 is 30 miles, 2 would be 60, 3 would be 90. But I need to go 250. So this purchase has to get me to a 250-mile limit, at least. Now I have an equation, and I can just follow the rules as I have in the past. Start on the variable side. What's happening to my variable? It's being multiplied. So I will do the inverse and divide by 30. G equals 250 divided by 30. The zeros are canceled. 25 over 3. And if I put that into a proper fraction, that's 8 1/3 gallons. Write an equation for each sentence. Solve the equation. The quotient of V and a negative 5 is 100. The quotient means to divide, so V and a negative 5 equals 100. Start on the variable side. What's happening to my variable? It's being divided by 5, so I'm going to multiply both sides by that negative 5. And when I solve, the negative 5's cancel on the left, leaving V equal to a negative 500. And my last example, again, I want to write an equation for each sentence and solve the equation. The product of a negative 5 and k is a negative 31. The product means to multiply. A negative 5 and k means equals a negative 31. Divide both sides by a negative 5. Why? Because what is happening to my variable? It's being multiplied by a negative 5, so I divide on both sides. And k equals negative divided by a negative is a positive 31/5. And this is simplified.